Hello, everyone. Thank you all for joining me here today. So excited. We're going to be talking about AI beyond the buzz. So I'm going to do a few slides just to sort of introduce how it is that we here at Wiz are thinking about AI security and the expansion of our platform to really help customers to secure really every single layer of AI applications, from code to cloud to runtime. But then I actually want to spend a lot of time in the demo itself, so hopefully you enjoy that. All right, so starting off with maybe just a little bit of history about Wiz, first of all. So Wiz started about 6 years ago, and it really sought out to solve the first challenge that we saw amongst our customers, which is the cloud shift, and that it changed everything for really development teams, first of all. Organizations all of a sudden had large development teams that were building cloud applications, specifically cloud native applications, and really they could go from an idea to something that was written in code that was deployed and running in the cloud environment in a matter of weeks to even days. So this meant development in cloud was very horizontal, very, very agile. And from a security standpoint, it meant that we actually had to adapt now to become faster, right, and to operate really at development speed. But the challenge that we oftentimes see is security wasn't really designed to operate in this manner. It's designed much more in a vertical, siloed type of approach. So I'll take an example here of React to Shell. And what we oftentimes saw is application security teams, they would run scanners that would look for it in the code environment. And they would see a lot of these, right, and have a really hard time actually prioritizing which of these should we actually ask our developers, who are very busy, to go focus on. Then in the pipeline, we have another set of tools and another team, often DevOps or DevSecOps teams that are running them, and they would look for React to Shell, but you may recall in the early days, there wasn't actually a fix available. So it's not like you can really do anything about it. So you let it continue and allow it to deploy. Then in the cloud environment, we see cloud security teams running a different set of scanners, typically that arose out of cloud security posture management tools. Again, you would see a lot of the vulnerabilities, but you wouldn't have a lot of context about if it actually exposed our business or exposed our sensitive information. And then in the runtime, our SecOps teams were using yet another set of technologies, right? They might be using a SIEM, or they might be using something that evolved out of endpoint detection and response, and they would find a few instances, but they also had other alerts that they were working at the time. And so because of this process, what we found is the real risks tended to slip through, and security did a lot of work, honestly, to sort of try to bridge this with manual effort. And it also led to really just friction between security teams and development teams. So the first step for Wiz was really how do we, I went the wrong direction there. So the first step for Wiz was actually how do we break the silos? How do we actually connect all of the dots together so that we understand a code finding, we understand where it was deployed in the pipeline, we see if it is actually running in the cloud environment, and we can also understand if it is actually being exploited, right? We see actually the IOCs in place. And this was the core of Wiz, right? How do we actually connect all of this context together on our security graph? And we do this across every type of risk, right? So not just a vulnerability, but looking at misconfigurations, identity issues, looking for sensitive data as well, and then of course, looking at AI risks as also. Now, once you have this core baseline understanding of what truly matters in our environment that we should prioritize, now you can actually democratize these findings out to the development teams, the business teams that can actually go fix this. And what we found is the security graph became that core foundation, the core understanding that both teams could agree upon that, yes, this is the thing that we should focus our efforts on. And the metrics that I am most proud of here are the ones in the bottom right here, which is the actual impact, right? So when we look at the active users in Wiz, we actually see that over 50% of them sit outside of security. So they sit within the dev teams and the DevOps teams themselves. So that means they are seeing the findings, they have the confidence that this is something that they're going to prioritize. And once you gain that confidence, they actually burn down risk on their own. So we see that actually 50% of our customers actually are able to achieve zero critical risk in the environment. So really incredible results. All right, we are now very much in the midst of a second transformation, which is the fact that AI changes everything again. From a what we build perspective, this is very, very different, right? At Wiz, our devs no longer write code. They have coding agents that are pushing out code at a rate I've never seen. I've never seen them ship so many things. We have PM teams that have agents that ensure our devs coding agents are never sitting idle. My team, we build agents for our sales team, for our support teams, so that they can communicate the value of all of the new capabilities and can help customers to actually adopt them. It's an incredible flywheel effect, but security is now responsible for securing all of these new use cases and securing all these new teams, right, that they don't traditionally have processes to work with. At the same time, of course, we are seeing the attackers use all of these new capabilities as well. And beyond that, we also hear about the new powerful models that are coming out and improving every single day that can detect these issues. So security has a lot on their plates, right? And really, how we see this is security has no choice but to also use AI and to change how they operate in this new world. Now, the good news about all of this is that AI actually operates very well when you feed it rich context. And as defenders, we actually have the most context about our environment. We have the home field advantage because we know what are our applications, what is our environment, who are the teams, which are the ones that are really critical to our business from a revenue perspective, and we understand what it is that our applications should be doing and how they should behave. So we can harness all of this. Now, I wanted to explain a little bit about how Wiz puts all of this together. So the first component for us is always starting with visibility, scanning the entire cloud environment, the entire AI environment, as well as the coding environment. And we scan across every single layer. So understanding the cloud infrastructure, understanding data and access, also scanning the models and scanning the actual applications themselves. We put this all onto the graph, and then we assess for risks. Now, once we find an attack path, or points of exposure, the next step is to now use AI against ourselves. So this is where our first agent comes in to play, and this is the red agent. If you were on the keynotes the last couple of days, you would have seen our co-founder Yanon demo this. But from our perspective, the red agent is actually the most powerful agent of all, because it allows us to actually now move to a dynamic understanding and a dynamic assessment of our environment. It means we're using AI against ourselves to give defenders the first mover advantage. So we understand the attack surface, and the red agent will probe every single point of exposure and really look for a path in that actually gets us to sensitive data or to excessive permissions in the environment. So once we have this, right, it's not just a potential attack vector, but it's a verified one that we know someone from the outside can exploit, and if exploited, would lead to significant business harm. Now, the next step is how do we fix at scale? So again, one of the unique elements of Wiz is not only do we understand the cloud environment, but we connect it all the way back to the code. What that means is every resource that exists in your cloud environment, we trace the lineage. What is the pipeline that deployed it? Where is the code repository where this code exists? What is the team that actually owns this repo? And who are the developers that actually last touched this code? This lineage is incredibly important for us to actually now start unlocking fixes all the way at the root cause. We also have an agent, which is our green agent. It's the fixer agent. It autonomously runs whenever we see one of these critical issues in the environment. And it does that full traceability. It does the tracing back to the source. It traces who actually is responsible and should own this fix. It will tell you, hey, this vulnerability was introduced in this line of code, and then we can push it to a developer. And not only can we push it to a developer, but we can actually push it to their coding agents as well, so that it can actually go implement that fix directly at the source, again, as fast as possible. So this combination is what allows us to really prepare security teams for this new world of AI. It means finally we can actually think about fixing being as fast as breaking or as fast as these new models are able to detect issues in the environment. It means we're able to finally release that bottleneck that we've always had when it came to triaging risk. All right, so a little bit more about how the technology itself works. So the first component, as I mentioned, was that deep inside-out analysis. We examine every layer of the cloud, whether that's public cloud or private cloud, potentially even on-premise as well. We understand that all agentlessly, meaning that we don't rely on the dev team to even tell us something, and then we install an agent or sensor onto the workload. We do this all with just an API-based connection, and it just means no deployment, right? 15 minutes, we start scanning the environment, and we put everything that we see onto the Wiz graph. So in this example, we see an agent. It's running DeepSeek and Claude Opus 4.6. It has access to different tools in the environment. Again, this just happens automatically. We're not relying on the dev teams or the AI teams to tell us that they did this. Security just knows that it's here. From here, we can layer on the context about this agent, this application that we have found. We can layer on understanding of who is the dev team that owns the code repository, where this comes from. We can now start understanding this service or this application. What are the resources that are related to it across different parts of our environment, like production and development? We can tag this as mission critical to our business as well. Next, we layer on the actual risks analysis itself. And then we can actually understand from the outside what of those risks are actually exploitable by an attacker. We do this not only from a risk perspective, but also from a threat detection and response perspective as well. Because again, SecOps teams also need the visibility into what are these new cloud applications or AI applications that we're building. And if they detect something, what is the potential blast radius? And arming them with really cloud-native approaches to actually contain and respond to these. Of course, if we see a risk or a threat, the key is always how do we fix this as fast as possible? And this is where we can really fix those risks in code. I'll go through this quickly because I'll just show it to you in the demo. And then the other side of this is we've been talking a lot about sort of like right to left, right? Code or runtime, or cloud and runtime back into the code. It actually works in the other way as well. So from code out to cloud, actually helping our dev teams with secure baselines, right? So you can think of it as hardened container-based images that strip out a lot of inherited vulnerabilities. And also enabling us to apply guardrails throughout the development process so that we actually don't deploy vulnerable issues to the cloud in the first place. So really all of this combines to create us that context engine, which is really powerful for defenders now to operate at machine speed. And this is the Wiz platform, right? So it is that unified approach from code to cloud to runtime. It works if you're GCP only or across a multi-cloud environment. But also if you think about where else are you running your AI environments at this point. It may not just be only in cloud. You could be using new technologies like Salesforce's Agentforce to more of a low-code approach to building agents. So really, that is the sort of core of what we think about the next phase of Wiz, which is how do we really enable security to get visibility and then assess risk and then actually be able to detect threats now to this AI application environment that we have. It means getting complete visibility across every single layer of an AI application and the development lifecycle that actually built it. It starts with the developer itself, right? What are they using in their IDE? What coding agents, what plugins do they have? Then the next step is actually understanding the code itself. Because the code is actually our blueprint for understanding application logic. We need to understand the pipeline that built the actual AI applications. We need to understand what's running in the cloud environment or SaaS environment. And then we need to understand what's happening in real time to really understand that live agent behavior. So that's really the core of Wiz and how we think about securing AI in this future path. Now, in terms of the announcements that we have for next, they fall into a couple of categories. One is really expanding the aperture of what we scan, because we have to recognize that AI is evolving very, very rapidly. Our teams are going to be building in a number of different ways. And as Wiz, right, we want to ensure that security is ready regardless of the architectural decisions that the business is going to make today or tomorrow. And so we've expanded our definition of cloud to cover things like Databricks, for example. It also means supporting all of these agent studios, whether that be Gemini Enterprise Agent Platform, could be Microsoft Copilot Studio, AWS has Agent Core, Salesforce, as I mentioned, has Agentforce. And we're going to keep going down that path to really double down and ensure security has that protection everywhere. It also means bringing more context into the graph as well, and connecting to the outer edge of the cloud. So think of this as your Cloudflares, your Apogees, or your Akamais of the world. We can now bring that in as well. And if your teams are building with Vercel, we will also include that as well. So all of the different sort of permutations that your business may choose, Wiz will secure it. On the other side, it's all about getting deeper into the actual AI native development lifecycle. This is actually super interesting and super exciting because when you think about it, we actually have all these new abilities to inject security in from the beginning that we never did before. One example is a preventative approach. We actually just released some plugins, Wiz hooks, as well as skills that you can leverage in Claude Code or Cursor. And what it means is you can think of it from a development standpoint as actually giving a security brain to your coding agents. So a developer says, okay, coding agent, I want you to build X. So it writes some code, and then it pauses after that. And it calls Wiz, and it says, okay, help me actually scan this code that I've just generated for security flaws. So it scans the code. It also understands, does this repo actually deploy stuff into my cloud environment, and can bring that context in. It can also bring in your company policies and understand what are the guardrails, what are the best practices that I must use. And then it will just rewrite the code to ensure that it's secure according to company baselines. And that means that by the time a developer has woken up, right, it's already code that has gone through a security review. It really means we can sort of stem the bleeding, if you will, and prevent right from the beginning. The other piece of this is closing that remediation loop even faster. So if anyone here went to the developer keynote this morning, we showed one of the examples of how this looks like, which is a developer sitting in their IDE. Again, it could be Claude Code, Cursor, whatever it is that your dev teams want to use. And they can leverage these pre-built security skills to say, hey, help me run a security check of the repo that I'm operating in, and help me suggest ways to make this code more secure. And it will automatically grab the green agent's findings and ask the developer, do you want to apply these fixes locally? And the coding agent will go ahead and do that, and then we'll validate the fix there. So again, really looking at how do we increase the speed at which we can fix. All right, so with that, I'll hop over into the demo. Okay, let's see. Hop over to the actual demo machine. Okay, so what you're looking at here is the core dashboard when you come into Wiz, right? As you can see, it looks at what are the threats in our environment, what are the risks that we should focus on, as well as the long-term sort of like hygiene that we should focus in on. Now, again, we're here to talk about AI because that is the theme of this entire week and maybe of our lives going forward. So I'm going to zoom in to specifically the AI security lens. So you can think of this as now zooming into all of the AI workloads and agents that we have in our environment. And again, it follows the core path of Wiz, starting with visibility into the environment, then assessing for the different risk findings that we have, prioritizing the attack paths that matter most that we should prioritize, and then also doing threat detection. Okay, so we'll walk through each of these in sequence. So the first is visibility, right? Everything in security starts with understanding what it is that we have, right? So every agent, every model, every MCP server, the technologies, and also understanding how they are grouped as a service within our environment. You can see this also extends into coding agents as well. Now, I wanted to show an example of something that we are seeing a lot within our customer base, which is the idea that anyone now, right, can build an agent. This could be our product teams and engineering teams, or in this example, we could have just a very young, eager guy from finance who's decided to build an agent for his CFO. And it's great for the CFO, right, because it can answer all of the questions that the CFO might have. Where are our customers located? What are maybe the teams that actually generate the most revenue for us as well? Again, amazing for the business, but you can see he might have connected a lot of information into this, right? A lot of data in order to enable this. So first question is, from a security standpoint, how do we even understand that this agent exists, right? This is someone really outside of our traditional purview. And this is where the visibility into agents, regardless of how organizations choose to build them, comes very important. And again, the core of Wiz works with just an API-based connector. So that means we are getting this visibility without relying on the teams themselves. So in this example, this particular data bot I know is actually running as hosted code. All right, come on, Wi-Fi, you got this. Okay, so we know that, I know that this one is running as code in our environment, so I'm just gonna go ahead and find this. Again, just to explain what is happening here, we're finding this agent. This is our data bot right here, and we see that it runs on this particular workload. Now, the way that Wiz is doing this is we are actually running now for every scanner in the environment, we're running 2 scanners side by side. One is a traditional heuristics deterministic scanner, and the second one is actually an AI scanner. And in this example, right, we are reading actually with the AI scanner every single piece of code that is running on this workload to find this agent. And not only do we find the agent, but we see that it is running Claude, and we can also see the tools that it has access to. So it can query a database, it can list tables, it can even execute code. And we also use AI to explain it to security, right? Because again, someone just did this. We're just seeing this for the first time. What am I seeing? So we are seeing a data assistant. It queries Postgres, and it implements tools that can access database and execute code. So you can think of this as almost becoming like documentation for security, so that they immediately understand the architecture of the agents without relying on this kid from finance or someone from the dev or AI team actually coming to explain it to them. Now, beyond that, it's layering on the assessments Wiz has always done. So understanding that this particular agent is internet-facing, and it looks like at least our finance kid vibe-coded a login page. We also see the identity of this particular agent, and we see that it has access to these 2 data stores, which we also scan and understand that we see PII information as well as credit card information. So this is that full potential attack path into the environment. Now we want to actually understand, are we exposed? Is this a true exposure that we should focus our time on? And this is where that red agent comes in. Again, it's autonomously running. Anytime we see that point of exposure, the red agent is going to attempt to penetrate it. Whether that's just network exposure or maybe a shadow API that Wiz has understood, it will go after it. And we trained it to think like an elite red team. And it walks you through exactly the logic of what it's done. So we hit the endpoint without credentials. Yes, it looks like authentication is there. But it passes in an arbitrary token, and it finds that it completely bypasses authentication here. So once we completely bypass authentication, we know we have full access to all of these endpoints, and the attacker can now reach all of the data that sits behind it. And it also has those code execution capabilities. So not only do we show, right, exactly that this is something that we should focus on, it gives us the exact reproduction commands as well, right? We proved it. There's no question that this is something that we need to go focus on. All right, this is a very validated risk. Our devs have confidence that we need to go fix this. So the next agent in play is actually our green agent. This is the fixer agent. This runs autonomously anytime we detect a critical or high issue. And it goes through all of the steps that a human would have gone through to understand every single component of this infrastructure, right? It goes through the graph, it looks at similar issues, it looks at the resource owner, it does that whole code to cloud traceability, and it compiles a full remediation plan for the team. So it says, okay, Roy Resnick is the person that is responsible for fixing this, so you should assign him the ownership. We understand that they had misconfigurations here, and this part of our infrastructure is defined as infrastructure as code, so let's go fix that in Terraform. We can see the authentication bypass vulnerability, and we see exactly how to go fix this in application code. And we also see that we're just missing, some basic controls, right, guardrails for our agent themselves. So again, we can push this to the developer, we can create them a pull request, or we can just send it to the coding agents that they are using. So let's open this up here. You can see now that we've basically have taken that entire instruction manual of how to fix things, the order of importance, and we've created a GitHub issue for it. And then we tagged in Claude, because in this example, we're using Claude code. And you can see Claude is starting to think about it, right? Because our coding agents now have a better understanding of our code than potentially the humans. And so Claude actually knows how best to implement the fixes. Now, this takes a couple of minutes, so I'll go to one that I already ran. And you can see exactly what it did. It went and fixed these 3 components. It committed the changes, and then it created a PR for the developer to review. This is what it really means for us to accelerate and remove that triage bottleneck and really ensure that if we find something, we have a path to fixing it fast. All right, now when I was on this issue earlier, this one, I also noticed that we saw an actual threat happening to the environment as well. So we can pivot over to this particular threat. Oops. Let's take a look at this one. Now, this particular threat is a suspicious prompt input that leads to remote code execution. It is the exact path that a threat actor has taken to exploit the risk that we previously looked at. And what we do here is, again, we correlate across all of the different layers of the environment. So our sensor understands real-time telemetry from the actual workload. We're looking at the model. So in this case, we're pulling in Bedrock invocation logs. It works the same way for Google Cloud and Vertex. We're looking at the queries at the data layer, and we also understand the control plane as well. So we are bringing all of this together, and this is actually 8 different detections that we are seeing across all of the different layers, and it's told as a single story, again, on the graph. So we see the machine, and we can trace all of the different processes that are being run that lead to it reaching out to this malicious domain that is masquerading as a real one. We can then see the identity of the agent that we just looked at. And the identity is actually taking a number of gets to the actual model. And again, we bring all of this information in directly to the SecOps team, and we can show you. These are actually all of the different prompts that are being pushed into the actual model. And then we actually see the final stage of this particular attack, which is that the attacker, now that has gained the full access of the agent, is now exporting the database that sits behind it out to something that it actually owns. We explain all of this also with AI because a lot of SecOps teams are very new to AI native threat detection. I mean, we all are, and we're all learning very, very quickly about what's happening. And again, we can now run an agent on this as well to really make this autonomous and accelerate the pace of our response. So here you can see our blue agent, and again, it goes through the full investigation process that a person would have gone through anyways. So it looks at the service, it looks at the configurations, it looks at how do we actually resolve threats typically in here. What does the communication look like? What are the model prompts that are happening as well? I will say our blue agent has gotten really, really good at figuring out our demo environment, and it tends to always classify these as planned actions in our environment as well. So this is really incredible in terms of now enabling SecOps teams to investigate fast and take action. Now, the other component I want to quickly show is the fact that we've been showing a lot of agentic capabilities, and it's great for teams. However, we also want the ability to actually understand what is happening. Sorry, it's cutting off. Okay, there we go. View workflow. Make it bigger again. So we understand some organizations, they want to move really fast, but other organizations, right, we have to build trust in the systems to get there. We need to really understand and orchestrate the human in the loop, the level that we need it in, especially across different parts of our organization. And so this is where workflows come into place. Workflows allow us to do this orchestration, to mirror in our business processes, but also to reach out to other tools that we have in our security ecosystem. So in this particular example, we see a threat. So whenever a threat happens, automatically grab me the blue agent and what it found. Let's put it into a very nice message that's intended for Slack with emojis, because we know people will respond if there's emojis. If we know that this is malicious, let's send this to our incident response team, and let's give them the remediation action right there at their fingertips so that they can take it. But if we're not confident, then yes, let's go do what we've always done, which is let's go ping our dev teams and ask them, was this you? So regardless of what it is that your organization wants to do, or whether you want to send this information to Google SecOps, right, the workflows are designed and to help you to create that level of customization for your business. And again, you can see that you can run it manually, or you can run this in an automated way. Again, to accelerate and to enable all of us to move at machine speed. This was a threat example, but of course we ship out of the box with a number of different ones, and customers can of course create their own. All right, so that takes us to the end of the demo. I think we've got a little bit of time left, so maybe we'll close it here, and I will stand up here at the front of the room if anyone would like to ask any questions. But I hope this was helpful. All right, thank you.